Welcome back, and we're going to be going on to lesson 8 of linear relations, and today we're going to be looking at writing equations to describe patterns. So for the first example that we have here, it says consider the pattern. What stays the same in each figure? What changes? Well, the four figures we have are 1, 2, 3, and 4. So we're looking at what is changing each time. Well, this is added on each time. So the squiggled section here, the shaded in section here, is the new addition every single time. So we want to figure out what is our pattern and how is this continuing through the figures. So it says below, complete the table. Determine a rule for the number of squares in figure N of each pattern. So figure 1, 2, 3, and 4, we know. In figure 1, this one over here, we have 1 square. In figure 2, we have 4 squares. In figure 3, well, we have 1, 2, 3, 4, 5, 6, 7. And in figure 4, we're going to have 10. Now, I already know that just because I can look at what the number of squares are increasing by. So from figure 1 to figure 2, it increased by plus 3. Figure 2 to figure 3, again, plus 3. And figure 3 to figure 4, again, plus 3. Now we're trying to figure out what figure N is going to be and the number that is going to be going here. Well, if it follows this pattern down, it should be 13. But we got to figure out if this is going to be right, and we're going to look at what is our telling signs for this. Now, our figure number, to our benefit, increased by 1 every time. So we had figure 1 shown, we had figure 2, 3, and 4 shown. Sometimes it might show you figure 1 and then go to figure 3, and you're going to have to figure out that difference. And that's where it comes in, that it's very important that you know what your formula is and what the pattern that's going to be followed. Another thing that's going to help us out to determine our figure number is if we look at what figure 0 would be. So if we had a graph, this would be where it's crossing over that y-axis. If our x is 0, it's where it's meeting that y-axis and would be crossing over. Now, if we followed that same pattern and we went from 1 and we were going, and instead of adding 3, we were going the opposite way, we'd be subtracting 3. That's going to bring us to 0 and -2. So -2 would be the y value for where it's crossing over or meeting at that y-axis. So the next thing that it is asking us below is what is the pattern in words? Well, if we look at this right now and we start off by looking at the figure number, our figure number is increasing by 1, and every time the figure number increases by 1, our number of squares is increasing by +3. So it's increasing by 3. So when we look at this here, it says, what is the pattern in words? Well, as the figure number increases by 1, the number of squares increases by 3. Next, what it's going to ask for us is what is the pattern using an equation? Now, remember when we looked at, well, if it was 0, it's going to be -2. This is where this becomes important to know, because when our x is 0, our y is -2. Now, what this is called our constant. And our constant is really important when we're writing out a formula, because our constant is going to be the value that we need to write down for that second part of the equation. Now we also have an n, and we have to figure out what is our rate of change for n. Well, every time our n changed, it was changing by 3. When we went to figure 1 to figure 2, it increased by 3. When we went from figure 2 to figure 3, it increased by 3 again. So our rate of change, I'm just going to write that down, this is our rate of change. So our rate of change is going to go in front of our n. So 3 was our rate of change, and it was a positive 3, so we don't need to put anything else. And to make this an equation, well, we're looking for the number of squares equals 3n subtract 2. Now looking at example 2, it's going to follow a similar part here. So it's going to be the same type of setup where you have figure 1, 2, and 3. So figure 1, figure 2, figure 3. Now your figure number is going to be your n, and your number of squares is going to be your s. If you look at figure 1, we have 1, 2, 3, 4. So we have 4 squares. Figure 2, 1, 2, 3, 4, 5, 6, 7 squares. Figure 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 squares. Now you'll notice that our rate of change is plus 3. Rate of change is 3. Say on this side, our rate of change is 1 and 1, because we're increasing the figure number by 1 every time. Now, our important step here is if we had 0, well, going back negative 3, because we're doing the opposite, we're going from figure 1 to 0, we're going to have 4 subtract 3, which will get us 1. Now this is, again, our constant. So that's going to become important when we're writing out our formula, and this is our rate of change, which again is going to be important when we're writing out our formula. So I've set this part up for you. Now I want you to finish off the rest of this by writing out what the pattern in words is, and also writing what the pattern is using an equation. So I want you to finish that part off below. Now I'm noticing that my papers have got a little bit out of order. This is going to be part of the second question that we go through. So you can write down in here and in here for what is the pattern in words and what is the pattern using the equation. Now I'm going to go on to the second part because you'll have finished that off and you'll have checked your answers in the class OneNote. Now looking at this second part here, what it asks is example 3. Write the equation to describe the relationship between the x and y value in the following table. So the first thing that we want to look at is, do we have our constant here? Well, they've already done the 0 for us, so our constant is 7. So label that. Your constant is 7. The next thing we want to look at is, what is our rate of change? Well, our rate of change here is 1. Again, 1. It's increasing by 1 every time. Rate of change on the y, From 7 to 9 is 2. 9 to 11 is 2. So our rate of change on the y is 2. Rate of change on the x is 1. When we're writing this out, if we wanted to find out what our y was, and we were using our x to solve, well, our rate of change would be 2 over 1. Your y is always written on top, and your x rate of change is always written on the bottom. Now we'll have our x, and then you're going to write your constant, so plus 7. So your constant will be the last part you write, and your rate of change will be on the top and on the bottom. So I have those arrows there to try and make that as clear as possible for you. Then you're dealing with y and x, but those variables can change dependent on what you are working for. So if you're trying to find c, if you're trying to find f, doesn't matter what the letter is, your variable can change. Now for this table here, we have x and y again. Our constant is already done for us. It's -5. So constant is labeled. Next, we want to look for what's our rate of change on the x. From 0 to 1 is 1. 1 to 2, 1. 2 to 3, 1. So I did 3 just to make sure. Rate of change on my y is -5 to -1. Well, that's plus 1. -4 to 3, plus 1 again. 3 to -3 to -2 is plus 1 again. So we have 1 over 1. So if we wanted to find y, we'd have a rate of change of 1 over 1, x subtract 5, because that's our constant. You could also write y equals 1x subtract 5, or y equals x subtract 5. All of those would be the correct answer. Now for this last table here, I'm going to leave this one for you to finish, but again, pay attention to what is your constant, what is your rate of change. That's going to help you make that equation. I'm going to instead write out a different example for you where we're still using x and y, but this time we're going from 0 to 5 to 10 to 15. So our rate of change for the x is different, and y we're going to be at 4, 0, -4, -8. Our constant is done for us because we have our 0 for x. Now we want to look for a rate of change. Well, from 0 to 5 is 5, 5 to 10 is 5, 10 to 15 is 5, did 3 to make sure. 4 to 0 is going to be subtract 4, or -4. 0 to -4 is -4. And last one to make sure is -4 to -8 is again -4. Now if I was to write out the equation for this, if I was looking for y, my rate of change comes first. So I have my y rate of change on top, my x rate of change on the bottom. So y rate of change is -4, x rate of change is 5. Now we have to put in our variable, which is x, plus my constant, which is +4. So if I was looking for my y value, I could use this equation now to solve for my y value. In example 4, it says an airplane is cruising at a height of 10,000 meters. It descends to land. This table shows the height of the plane every minute after it began its descent. The height of the plane changes at a constant rate. So our rate of change is going to be constant all the way through this. So that's just an added piece to make sure we know that this is going to be a constant rate of change. Now looking at the information we have time, which is t minutes, and height, which is h meters. They give us our 0 value for time, so we're starting off at 10,000 meters when they first started taking the time, and we want to look for what's our rate of change for x, or for time in this instance. So it's increasing by 1 minute every time. Our rate of change for a y, or in this case our h in meters, is going from 10,000 to 9,700. So we lost 300, so negative 300, from 9,700 to 9,400. So negative 300. So our rate of change is staying consistent for this question. With this information, we can now complete the questions that are at the bottom. The first one is write an expression for the height in terms of the time since the plane began its descent. So, for A, we want to write an expression. Now, an expression is different than an equation. An expression does not have an equal sign. So when we're writing this out, we're not going to be writing h equals or y equals. We're just going to be writing out what is happening. So we have our rate of change, which is negative 300, and 1. So negative 300 over 1. Now, what was changing? Well, it was our t for time, plus we have to think about what was our constant in this. Well, our constant was 10,000 because that's our starting, where we had a 0 value for time is 10,000. Now that would be our expression. If we were writing an equation, this is where h equals 300, no, that's negative, over 1 t plus 10,000. This would be our equation because we can actually calculate something here where an expression doesn't have your equal sign. Now, if we wanted to, this could also be h equals negative 300 t plus 10,000. Now, if you don't put it over 1, that is okay, because that 1 on the bottom isn't going to affect anything. For C, it says, what is the height of the plane after 15 minutes? Well, now we can use this equation that we created to calculate for this. So t equals 15 minutes, because we want to find out what's the height at 15 minutes. So h is going to be our height, negative 300. T is going to be 15 because that's our 15 minutes, plus 10,000 because that's our constant. H equals negative 300 multiplied by 15 is going to give you negative 4,500 plus 10,000. Take this further, h equals, so your height equals 5,500 meters, because that's what we're measuring our height in. So we're at a height of 5,500 meters after 15 minutes. D is our last part for this. It says, how long after beginning its descent does the plane land? So we want to figure out, when is h going to be 0? So when is our height going to be 0? So that's going to be on the ground. H equals negative 300 T plus 10,000. This is our equation that we're using. This time, instead of changing the T, we're putting in 0 for H because we want to know when we're getting to the ground, how long it's going to take. So T stays there. Now we have to manipulate this equation. So we have to bring over the 10,000, which you have to do the opposite. So subtract 10,000. What you do to one side, you have to do to the other. So subtract 10,000. So you have negative 10,000 equals negative 300 T. Well, we have to get this negative 300 off of the T. Do the opposite of multiply, which is divide. So divide by negative 300. Divide by negative 300. And negative 10,000 divided by negative 300 is going to end up equaling 33.3 minutes. So this is going to be our final answer for how long it's going to take to get to the ground. Following this, there's example 5 and example 6, which is going to look at similar concepts. Now remember, we want to pay attention to what our constant is going to be and also look at what our rate of change is. Well, if this is the fixed cost, this is going to be our constant. And if it's plus $1.50 per kilometer, when you ever see that it's per something, it's going to be your rate of change. So this is going to be your rate of change, which will be important when you're making your equation. So that'll be your rate of change. Now you have enough information to answer the following letters below. For example 6 here, you're going to be looking at another very similar type of equation. And remember, the first thing that you want to look at is what is your rate of change and what is your constant. That's going to help you build your equation so that you can solve for the following questions. Now, that should be enough information to get you going on these worksheets, and there won't be any practice questions following this, so we're going to be using these specific questions as your practice questions for today. So once you're done these questions, make sure you go and check the class OneNote and see if you got the answers correct. If you do have any questions, please make sure you're sending me an email, and I can go through any of the questions with you tomorrow or later this week. Other than that, have a good day.